I'm Patty Simpson with Simpson Math. In this video, we're going to begin our discussion on how we collect data. So remember, in statistics, what we have is some question that we want answered. And we answer it by collecting data and using that data to answer our question. So we would love to, when we are collecting data, be able to collect data from our entire population. Remember that the population is our entire group of interest. But collecting data from the entire population a lot of times takes time and money and manpower, and so it's very, very difficult to do. So instead, what we do is we just collect a sample. We collect data from part of our group of interest, and we call that a sample. And samples are collected because it is so difficult to gather data from the entire population. When we are able to gather data from the entire population, we call that a census. But that's really hard to do. So we just collect samples instead. But that sometimes causes problems. What we want when we gather a sample, when we gather data from a sample, we want a representative sample. In other words, we want to gather data from a part of the population, from a sample that looks like the whole population. So a representative sample has the same relevant characteristics as the population, and it doesn't favor one group from another group of the population. So for instance, if I was interested in pecan trees in my orchard, I don't want to go out and collect data from the entire orchard. It would take me too much time. So instead, I just gather data from some of my trees. But I need to make sure that I'm gathering data from some trees from each area, or trees that look alike. In other words, maybe I've got really tall trees and I've got really short trees, or maybe I have different types of trees. I need to make sure that I gather data from all the different types of trees I have, from tall trees and short trees, and I'm not just all my trees look alike and I'm excluding others. So a representative sample looks like your population. It's part of the population that looks like the entire population. So a statistical bias in statistics is different than just the word bias that we typically think of. When we typically think of bias, we think of having some personal reason to favor one group over another. That's not how it is in statistics. Statistical bias is just the tendency of a statistic to overestimate or underestimate a parameter. In other words, when I collect data from a sample, there is a tendency for that sample to be a little different from the whole population. I want it to be representative, but it's not always exactly perfect. So there's some tendency for it to be a little bit, our statistic to be a little bit more or a little bit less than that entire parameter. When we have an unbiased statistic, that means that if we take a bunch of statistics or a bunch of samples and we gather statistics from that and we get an average of those, it'll really be like the parameter, the population parameter, and we call that an unbiased statistic. But statistical bias is just that tendency that our statistic and our parameter are not quite the same. And there's some different causes of that. Sometimes there's just measurement error. When we go out and collect our data, maybe we collect the data incorrectly. I'm weighing a baby, and instead of writing down 9 pounds 7 ounces, I write down 7 pounds 9 ounces. So that the data I collect, I actually record inaccurately. Or maybe I ask a question, and the way I ask the question makes my person who's answering it not answer it correctly. Maybe not because they intended to misunderstand, but maybe they just misunderstood the question. So measurement error is one reason for statistical bias. Another reason, and up here it says that the recorded data just differs from the actual values. So measurement error might be caused by the way that an interviewer poses the question. Maybe it's the wording of the question. Maybe it's the way that I collected my data. Like I said, I wrote it down wrong. Or maybe it's the way that the respondent recorded their data, if I'm relying on them to record their data. Sometimes, though, statistical bias is because I have an unrepresentative sample. You know, I didn't realize that there was a whole group of trees that I'm missing in my population. You know, there was a group of trees that's being inundated and flooded with insects, and when I collected my data, I didn't collect any data from those insect-ridden trees or whatever. So if I collect data from an unrepresentative sample, then it too can cause statistical bias. And when I have that statistical bias, I end up with sampling error. When my statistic is not exactly the same as my parameter, I have some statistical error. And to find that statistical error, I just find the statistic minus the parameter, and that equals the error. I think there's supposed to be an S right there. Statistic minus the parameter, and that equals our error. So here's a small introduction to gathering data and some things that can happen when we have a sample. We collect a sample. In our next videos, I'm going to tell you about different ways that we can collect samples from our population. Math Made Simple, it's some math. Thanks for watching.